In this lecture, we're going to look in depth at the ML agent system and what actually comprises everything. So what are all the components and how they kind of fit together and work for us. So we've already gone through this ball example and we're going to recreate it but with just one platform. So we're going to create a new scene. So we go up to File and I'm going to create a new scene at the top here. I'm going to stay inside of this ML Agents project that I've already opened up because it's set up with all the Python stuff in that subfolder and it's got all the plugins and all that sort of thing. So, why make things more difficult for ourselves? Inside of this examples with the ball and the other things that Unity gives us, let's create a new folder and we will call that folder, let's just call it My Ball, that'll do. And then in My Ball is where we'll put all of our resources. So that includes this particular scene we've just created. So let's save the scene in that My Ball folder and just make sure that it does go into there. My Ball. And what shall we call it? Oh, well, probably My Ball would make sense like that. Okay, so now we've got that scene. We need a platform, so let's create ourselves a 3D object cube and we will make that cube flat. So we will just stretch it out, so hit the R key to do that and flatten it down like that. Now, if you want to change the color of it, then you'll need to make a new material, create new material. And let's make it blue. So we'll call it blue. We'll set the material to a nicer blue color. Oh, let's go with purple. That's holistic 3D colors. So go with purple, even though it's called blue. Okay, so there's our platform. Now we want to possibly angle our camera to be looking at that sort of a view. So we'll select camera, game object, align with view. There's that. Now, if you want to maybe change the background color as well, so it's a flat color on the camera, go to solid color on the skybox, and we will set that to something quite dark like that. And it just, those colors have just given me the idea that we need a bright green ball sitting on here. So let's create a sphere, 3D object sphere. Hit the W key to lift it up a bit. Might just make it a tad smaller. Kind of want it sitting, about there. And I'll duplicate my blue material. Call it green. And then put this to a... This is probably going to be way too difficult to look at. I don't know, that's all right. Why did I pick these colors? I used to have these colors when we used to program on the screens from the command line in Unix and that. I used to always change my screen colors so that I had like purple and green text coming up. So this just reminisces back to when I was doing that. Of course, you can set these to whatever color you like. So now we've got our basic setup. We've got our platform, and the platform is going to have our brain controlling it, and the ball is going to be under the control of physics. So that reminds me, while we're here, select the sphere and let's add a rigid body to it so that it will be under physics. And the cube, which is now our platform, let's call that platform. We will also add a rigid body to it. And we will make that is kinematic because we don't want it to be affected by other physics in the scene. All right, so let's just save that particular setup. Next, we're going to add in an event system into the hierarchy. So right-click in the hierarchy, you want to go down to UI and right down to event system. We're going to be programming this to accept arrow keys a little later on to move the platform manually by hand, and we need this input. You don't need to change the settings, you just need to have that event system there. Right, so now we're ready to add our academy first. So let's create an empty object and we'll call that academy. And as a child to the academy, create another empty game object, and this will be our brain. Now the brain has the component of the brain script, which already exists when you've got the plugins and that installed here. So just type in brain under you've gone add component and find it, and just click it on here. Now it's going to give you an error saying that the parent needs to have an Academy component attached to it, which is right. We haven't written that yet, but we will need this brain code in a bit. So the first thing we will now do, go back to our Academy, we're going to create a C# script in here, and we will call it, let's call it My Ball Academy. Why not? And we will attach that to the Academy in the hierarchy. Just check that got attached. Yep. Okay, and now we're going to edit it. Now, there's really nothing going on in the Academy. The Academy itself needs to be made Academy, inheriting from that. Also, the reason why I didn't just call our own script Academy, so don't do that, because you've got to inherit from this. And then inside of that, we're just going to add 2 empty overrides like this that just need to be there and pretty much to satisfy the brain code that we're going to write later on when it starts to run. So that's all you need for the Academy. Save that. And now we need to write the code to control the platform. So our platform is here. It's the purple one. The brain drives the platform via an agent script. So we need to write that agent script. Let's create a new C# file, and we'll call it My Ball Agent, like that, and we'll open it up. It's going to inherit from agent, like that. Now we'll save it, we'll switch back to Unity. At this point, I just want to see if it's going to give us any errors. No. And go over to the platform, drag and drop that My Ball agent onto there, and you'll immediately see the inherited values that it needs, and see how it's got brain in it. That's where you then attach your brain that's in the Academy, because you want this brain to run this agent, which tells the agent what to do. So in the agent code itself, back in here, is where we write all of the controlling type code and the state setting and that type of thing. And this will look quite familiar because we did it ourselves when we created our own Q-learning neural network. Now what the agent's doing all revolves around what the ball's doing. So we need the agent to know about the ball. So we'll add a public game object ball that we will bring in via the inspector. And instead of start and update, remember this is inheriting from our agent class. So now the flow of the program is controlled by the ML Agents plugin. So we don't control it with start and update and all that sort of thing. So we need to override the methods in there and use each one for what they were designed for. The first one is going to be where we define the state of the environment and the state of our agent. And it's called collect state, and it returns a list of float values. Now I was using doubles when we created our own neural network, but you'll see a lot of floats going on around here, which is probably more efficient than the way we did it with our doubles in our actual code. Anyway, it's the same thing. You still got a list of values, and these are the states. Now these states here, we're going to get our Z and X rotation of the platform, because remember it's going to rotate in 2 directions this time, unlike our other platform that we created. It's also going to be getting some other states. So it's getting the difference between the ball's X position and the game object X position, the Y and the Z. So it's not getting the absolute position of the ball, it's looking at where it is respective to the platform. And then it's also getting hold of the ball's rigid body velocity in X, Y, and Z. So these are the same sets of states that are being sent through with the multiple ball platforms in that project that we already built before. Now you might want to experiment with this and make less states, because remember, less states keeps the whole thing much more compact and easier to train. But anyway, these are the ones that with that example. So we're just going to go with that. So this is our collect states that we're going to get with the ball. At this point, we can save it. We can switch back to Unity. We can select our brain. Our platform. And we will have an exposed value for the ball. And at this point, we can grab our sphere and drag and drop that into that spot for the ball. Okay, so now let's go back and keep editing our script. And the next will be familiar to you. It's agent reset. So this is what's going to happen when the game resets, like the ball gets dropped and we go back to 0 to start again for our training. You'll notice that this is not just reset, it's called agent reset. These names of these methods are overwritten from our agent class and are non-negotiable as to what their names are. So make sure that you've got them spelt exactly right. Otherwise, the system won't be able to find them when it tries and run it. What the agent reset is doing is it's setting the rotation of the platform back to 0 and zeroing it for us, and setting our velocity of our ball back to 0, and also setting the position of the ball back to a ball start pos, which we haven't yet defined. Same thing that we did with our own ball on the platform from before. So we need a vector 3 to store the ball start position. And then we need to do a void start. I know I just took this out. Isn't that annoying? Ball start pos. It's going to equal the ball.transform.position that it starts in the very first time we get hold of the ball. Okay, so that's going to move it back to that start position. Right, so just save that. And now we'll write the method that's doing all of the physical controlling of the platform. So this is where the actions get converted from quality of which action is the best, so the max Q type values, into actual movement of the platform. So let's just add this method in, and I'll come back to the top. So it's called agent step, and you're going to get passed in a float array of actions. So these floats will have values, and the length of it will depend on how many different types of actions that there are. So with our agent, for example, before we had 2 actions. We had tilt left and we had tilt right. So if this was our agent, we could expect 2 of them to be coming in. Now, to add a slight bit of complexity in the way these agents work, you've got 2 choices between the types of action values that you're going to get. And you can get discrete values or you can get continuous values. When using discrete actions, the actions are stored in a single value and they're coded according to how many there are. So you have a list of size 1 or an array of size 1 that can store up to action number of values. In this case, we've got 4 values. If there's a 0 in there, it means that you want to rotate in the negative Z. If there's a 1, rotate in the positive Z. If there's a 2, rotate in the negative X. And if there's a 3, rotate in the positive X. With continuous values, you can store not only the action that you want to take, but a value that represents how much of that action you want to take. So the types of actions we stored when we made our balancing ball previously were continuous actions because they told us which action to take, so to rotate Z or rotate X, but we could also use the value in there as the amount to rotate as well. With discrete actions, you store the amount to rotate separately. You'll see both continuous and discrete dealt with in the code of the agent step. So if the brain parameters action space type is set to continuous, and I'll show you where to do this in a moment, then we will have 2 values come through in this array here. 1 for rotating in Z and 1 for rotating in X. And because they're continuous values, we can have them go into negative and to positive. And you'll see in these transforms that we're using on the game object itself that we're rotating around the Z using whatever value is in position 0 of that action array, and around the X with whatever position is in the second spot in that array. So these values here are going to also be amounts and continuous values. Once we perform any type of action, and you'll see this throughout the code, we then test for the reward situation. And we'll come back to this in a moment. These are internal values, this done and reward, and we're using them to set what the reward is. So after we've executed this action, then we go, if done is false, then the reward is 0.1. So it's a positive reward. From here, you could determine that done equal to false means we haven't dropped the ball yet, and so done will be set to true when the ball gets dropped, and that will happen elsewhere. But it's just important that after every action that you've got your decision for, that you do something to set the reward amount so that it can then go into the memory of your action rewards. Now, if we've got a discrete state, then we're going to have a little bit different code, because remember, we're going to have an array that has a list of actions that are coded, essentially. So for each action you can possibly take, there will be a number that represents it. And so it only needs to be one integer long, where 0 means do this, 1 means do that, 2 means do that, 3 means do that, etc., for as many actions as you've got. Okay, so in here, I've just got a debug log. Obviously, I was looking through the code trying to determine what my values were coming up as I was testing. Also good practice to put in there for you. First of all, what I'm doing here is if action is equal to 0 or 1, that will mean that we're doing a Z rotation, and you can see that down here. If action is 0, that means we'll do a negative rotation, and if it's 1, then we'll go and do the positive rotation. The amount of rotation is not stored with the action, so therefore you need to code it in. In this case, I've just put 2 in here as what it will be using for its amount of rotation. It's the same as our tilt speed that we had before, and you could probably should create this as a variable at the top that you can set so that you can change it in one spot. Now, if it's not 0 or 1 for the action, it's 2 or 3, then that's our rotations around our X, negative and positive, again by the amount of 2. Then inside of here, for this discrete part of our else statement, we're again doing this. If we're done or if we're not done, then we'll give a reward. Now, when we are done is when we drop the ball. So if we come down here, we can see where that code is. Now, this code is determining done depending on where the ball is with respect to the platform. And you can see here that the Y values, the X values, and the Z values, the distance between the ball and the platform, are being compared to see if the ball has fallen off of the edge. And you could replace these with the same kind of collisions that we had in our code in order to set done to true when we've dropped the ball, and also to give ourselves a negative reward in here. Notice these two values are part of the agent class. Okay, so they're defined inside there. We're not declaring them ourselves. All right, so that is the agent movement code and the actions that will come through. Now, the nice way about how this is all set up is that you can get your actions to come from your neural net. You can get your actions to come from some kind of clever code that you wrote, or you can get the actions to come from the player. And getting them from the player is quite important to test the way you've got this set up, that the platform is going to move how you expect it to move. So save your code, and when we come back in part 2 of this series, we'll look at setting up the player to control the platform. Thanks for watching. Please support the development of more superb online learning content by subscribing, and as always, visit holistic3d.com to learn more about awesome games development books and tutorials.